Okay. All right, let's see how to do this question. So this question is similar to last week's question. Okay. So they're telling you the one with water is called hydrated. The one with water is called hydrated. It has 7.3 grams of the hydrated one. The one without water is called anhydrous, right? I told you before. So anhydrous is 4.6 grams. So can you find the mass of water? Yeah, you just have to minus. So, Ian, right? Yeah. Okay. I don't have. No, wait, okay, I'll go through the last six questions. I don't think I have. I asked Mr. So the mass of water you just minus lah. Okay, so it's 2.7 grams. Correct? Okay. So the first thing you do is you find the amount of moles of water. Mass over molar mass. Okay. So you get 0.15 mole. That's of water. Okay. Now, the mole of magnesium bromide, this one you need to look at the periodic table. So magnesium is 24, bromine is 80 times 2, so you get 184. So the moles of magnesium bromide. Okay, I do want to hear for you. You find the moles of magnesium bromide and then you find the ratio of the two and then you find the value of X for me. Go, quick, quick, quick. Try. Do you have an exercise book? I have a spare one. You can use it. It's blocks, but it doesn't matter. Lah. You just have to write your notes and whatever, working and everything. Thank you. Okay. Did you get did you get these two answers? Did you get this one? This one and this one didn't get. Okay, why? Okay. Jonathan, you know how to count out, Jonathan? No. Okay. So after that, you want to find the value of X. You just find the ratio. So how to find ratio? You just take the big number, divide the small number. Okay. So you will get how much? 6. So X equals to 6. So the formula is MgBr2 dot 6 H2O. Can you understand? Later I'll share the recording to the group chat. Then you can also look at the old recordings. It's okay. Okay. Can? Did you do question 12 already? Huh? No. Jared, did you do question 12? Do. Eugene? 12 done already. Okay. What mass of hydrogen is produced when 10 grams of aluminium? So they're telling you here is 10 grams. How much is hydrogen? It's not that hard. Okay. So whenever you don't know what to do, you always find the amount of moles. And since they give you grams, amount of moles is mass over molar mass. So the mass is 10 grams. Molar mass of aluminium, you look at the periodic table, is 27. Okay, so you take 10 over 27. So you get 0.37 mole. Okay, can? Alright, so now what happens here is they're asking you, I got this much aluminium, yeah? You don't need to. No. Al2O3 you times 2. The 2 in front is just to balance. Calculating molar mass, you never times the number in front. You never. The number in front is only for comparing the ratio. So they're looking for aluminium to hydrogen is 2 to 3. 2 to 3, like that. So if this one is 0.237, how much is hydrogen? How to count? Times 3 divided by 2, because the ratio is 2 to 3. Okay, so times 3 divided by 2. So 0.37 times 3 divided by 2. That's your moles for hydrogen. Get it? Okay. So you get 0.555 mole. Okay, so Jared, now I want to find the mass of hydrogen. I want to find the mass of hydrogen. How do I do that? So mass of hydrogen will be moles multiply molar mass. So do I take 3H2 or do I just take H2? H2, get it? Alright? So times 2, because hydrogen is 2. Ariel, Jai not here. Ariel is late. Yeah.
Yeah, Europe probably has
Bad.
yeah, so
This is the new student Ian. I asked Mr. Gong to send like photostat one more set notes.
oh, so I haven't received that.
Yeah.
Okay.
Yeah, help me out.
It's for chemistry, is it?
Yeah, chemistry only. Yeah, chemistry. Yeah.
For like
Okay. Thanks, yeah. So 1.11 grams. Okay, can get it? Okay. I'm gonna give you something. Okay, we're not gonna use the whole set yet. We're gonna use it eventually. So this one set got 10 pages, but I want you to look at page 10, the one at the back first. Okay, can? Alright. Left ear. Take one and episode. Okay, so look at page 10. Okay, so page 10 is the exact same question. It's literally the one at the back. Yeah, the one at the back. You all finished copying already, is it? Not yet. Okay, copy first. Look at page 10, question 16. Can you see? Page 10, question 16. It is the exact same question as this. Okay? So it's exactly the same concept. Not this one. As this, sorry. As this. Exact same concept as this, okay? We're supposed to find the value of x. Can you do that? So you just follow the sequence. Can try? Okay, after you've done this, we need to do something else really. I want to teach you empirical formula. Alright? So let's look at this. On analyzing the crystal, okay, the student found that 1 mole of hydrated iron 2 sulfate contains a mass of 278. Okay, mass of 1 mole is molar mass. Iron is 56. Sulfur is 32. Oxygen is 16 times 4. How much does that give you? 152. Okay. Calculate the mass of water. So you take 278 minus 152. How much did you get? 126. Okay. Value of X, all you need to do is take 126 divided by molar mass of water. How much is that? Huh? 7. Okay. Okay. Easy, right? Okay, so that's all. We're just looking at ratio. And so far, all we have been doing is just calculating amount of moles using the first formula. And what is the first formula? Mass over molar mass. Because everything I've taught you so far is just mass, 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 mass. Okay, so you just remember mass over molar mass, mass over molar mass. Just remember the first formula. All right, so now we're going to use this formula and find something called empirical formula. Empirical formula is a formula that shows the smallest ratio of atoms of an element. Okay, so for empirical formula, we only use this formula. Okay, this formula, sorry, 18. 18 is the molar mass of H2O. Because this is the mass of H2O. So it's mass over molar mass. H2O, hydrogen is 1 times 2, oxygen is 16, so 8. Okay, yeah. So mass over molar mass, we're just looking for ratio. So for example, MgO. Okay, everybody knows the formula MgO, right? So MgO doesn't mean 1 gram of magnesium react with 1 gram of oxygen. No, that's not what it means. MgO means 1 mole of magnesium had reacted with 1 mole of oxygen. That's what MgO stands for. Okay, Kat? So, for MgO, it means the ratio of magnesium to oxygen is 1 to 1. Okay, it's like ratio of students in your school. Okay, let's say if I say the ratio of students in your school, girls to boy is 1 to 1. Does it mean that your school has only 1 girl, 1 boy? No, okay? But maybe you go to a very small school, really got 1 girl, 1 boy. Okay, your mom just teach you and your sister. I don't know. So, let's say I put a ratio of 1 to 1. That means the ratio is 1 to 1. But if I tell you your school has 500 girls, that means your school also has 500 boys. Right or not? Okay, so that is what ratio means. Empirical formula is showing you the smallest ratio. So for example, glucose. Who can tell me what's the formula of glucose? C6H12O6. That means one molecule of glucose actually has 6 carbon, 12 hydrogen, 6 oxygen. It actually has that. But if I want to find so this is the actual formula. Actual formula is molecular formula. So if I'm trying to find the empirical formula, it is CH2O, simplest ratio. Do you understand why? You divide by 6. Okay, so carbon 1 to hydrogen 2, oxygen 1. All right. So look at the previous paper. This one just now the calculation one. And look down, look at this page. Task 18. I think it's the last page of this. Task 18. Can you all find it? It's written here, task 18. The old paper, not the new paper. Task 18. Okay, so empirical formula is basically smallest ratio. Okay, so let's do just a simple exercise just to warm up. Can you do question 1? Just to warm up. Okay, just to know what you're doing. So this is the molecular formula. These are all molecular formulas. That means it's the actual formulas. Okay, now? Easy, right? So look at this. This one, the ratio, simplest ratio is 1 to 3, so CH3. This one it's already the same. It's already simplest ratio. You cannot simplify it somehow. This one also already simplified. Cannot simplify anymore. This one can. CH2. Get it? Okay, this one can or not? Can. CH2O. This one? No, this is already simplified. This one is B3H5. This one can simplify or not? No, it's already the simplest. Can you understand? So these are showing you empirical formula. So sometimes empirical formula is the same as the molecular formula. So molecular formula is the actual molecular. Empirical formula is the simplest ratio. Okay, this is the easy part. Now, how do I find it? Okay, how do I find these numbers? Usually, scientists will analyze. So they find calcium bromide and then they will analyze it, analyze it, analyze it. And then they say, oh, inside calcium bromide has 20% calcium, 80% bromine. Find the empirical formula. Okay, this is not, oh, teacher, I know. Oh, very easy, very easy. Simplest ratio. I know how to do. Calcium 20 BR80. Oh, no, I know why you're angry because it's supposed to be simplest ratio. BR80. No, guys. No. If they give you percentage or they give you mass, it's the same concept. You need to find amount of moles. How many million formulas have I taught you? One. Mass over molar mass. Okay, so you have no place to do it here. I will encourage you to use the exercise book that I've told you to bring like 3 times already, right? Right. You have exercise book or not? Yes. Okay. So you either use exercise book, please step paper, whatever you have. Do you have a specific book for chemistry? Do you want a specific book for chemistry? It's 大房、小房、中房, but never mind, just write over it. Yeah. Somebody gave me a lot of these. Okay.
Feelings.
Yeah, free books. I have so many of these. Nobody uses it. Okay. So what I suggest you to do is uh do it that because if you squeeze, and please don't lose your paper or your book or whatever, okay? So most of my students they have a notebook where they keep everything. Okay, so we're gonna try the first question. I'm gonna explain how to do. And you must always use the same method. It's very, very easy. Okay, it's very, very easy. So first, you always do the table method. Okay, like this. So calcium, bromide. Okay, first you write down the percentage or the mass. It doesn't matter. The mass and the percentage is the same thing. Why? Teacher, it's not the same thing. So if they say 20% calcium, 80% bromine, it means that in 100 grams, 20 grams is calcium, 80 grams is bromine lah. Same lah. So it's the same concept. Okay, so don't worry about that part. Okay, and then we find moles. So the formula of moles is mass over molar mass. Mass over molar mass. Of course, now I'm showing you example. Molar mass can find in the periodic table. Bromine is 18, calcium is 40. Okay, so 80 over 80 is 1, 20 over 40 is 0.5. Okay, please don't do this. Ta-da! I will sit down here and cry. Please don't do things like this. Okay, so how do you find the actual ratio? Okay, this one you look in molar 1 and 2, but let's say it's funny numbers. What do? You always divide the smallest number. Who is smaller, 0.5 or 1? 0.5. So you take 0.5 divide 0.5, you get 1. You take 1 divide 0.5, you get 2. Ta-da! CABR2. That's it. Empirical formula. Okay? Okay? Alright, now let's try one more. Okay, so try the okay, try D. Okay, now I want to explain to you something. Okay, try question D. Use the same concept. Yeah. Okay. Let's do it together. Okay. So the question Jared has is, do we round up? So 2.73 over 12. Okay. 7.27 over 16. So I get 0.2275 and 0.454. Okay. It's kind of funny numbers. Always find the ratio, divide the smallest number. Okay, 1.99, can I round it up to 2? Yes. So it's 1 to 2. Okay, which comes to a very important question. Okay, so this formula is CO2. Can I always round it up? Okay, did you guys get CO2? Did you guys get CO2? Yeah? Yes, okay. So Ian can follow, okay? Alright. So what if, so this one is 1 to 1.99. It's very obvious. But what if it's not obvious? Then how? So then we go back to our notes. Look back at the notes here. Okay, look up here. Sorry, not up. Where is the number? Here, this one. Number 3. Look at number 3. So sometimes you will get like what we got just now. 1 to 1.98, 1 to 1.99. So very obvious. So the answer is 1 to 2. But we don't always get this kind of beautiful numbers. Okay? So 4.97 to 1 is obviously 5 to 1. Okay? But what if it's 1.5? Haha, 2 to 1. No. If it's 0.5, you always times 2. 0.5 you times 2. Then you will get 3 to 2. Okay? So this one is 0.5 you times 2. What if it's 0.3? 0.3 and 0.6 times 3. Multiply 3, okay? 0.5 times 2. 0.25 and 0.75 times 4. Can you remember? Okay, so if it's 0.25, 0.75, you multiply by 4. If it's 0.33, 0.66, you multiply by 3. Okay, try and see. Then you get different answers. See.
This ways of like which to number numbers closest.
Yes, whether you round up or go round up.
Oh,
So how you get a ratio? So this one you will get a 3 to 4 ratio. If you simply put, you will get a 1-to-1 ratio, it will be a wrong answer. Uh, can you see the concept? So you don't always simply round up, round down. If it's 0.5, 0.33, 0.66, 0.25, 0.75, you have to make it you have to multiply it until it becomes the nearest round number. Make sense? Okay. So, Hannah, okay, this is what I want you to do. I want you to do question 5. Open your eyes big and read carefully. This one is 3.53 grams of iron reacts with chlorine to form iron chloride. So is this the mass of chlorine? No, this is the mass of iron plus chlorine. So how do you find the mass of chlorine? Minus lah. Okay, do number 5. Okay, do number 5 and do number 6. 6 is the same, except 6 is 3 elements instead of 2. You just have to minus. Open your eyes big and read carefully. Read carefully, okay? I think 90% of the problem you get wrong in school is because you just don't read properly. Okay, so read properly. Do you get FECL3 for the first one? Okay, that's that. No, okay. Yeah, sure. Can I? Okay, do you get K2SO4? You get it? Yeah?
Yeah.
Okay, understand now? All right. Okay, now let's go to the last part. So we know what is the empirical formula. Okay, we already know what's the empirical formula. Now we're going to get the empirical formula and then we're going to find the molecular formula. What is molecular formula? Empirical formula is the smallest ratio, right or not? Molecular formula is the actual amount. So, for example, this is NH2, the empirical formula. We don't know what's the real formula, but we know that the real formula, the molar mass of the real formula is 32. So all we need to know is how many times bigger. All we need to know is how many times bigger. So like this. So NH2, nitrogen, hydrogen 2. Nitrogen is 14. Hydrogen is 1 times 2. That gives me a total of 16. So all I need to do is take 32 minus 16. This value we call N. We take the molar mass of the real molecule divided by the empirical formula mass, and then we can get N. So 32 is the actual one, 16 is the molar mass, and then we get 2. So that means this empirical formula is NH2 multiplied by 2. So the actual formula here is N2H4. Can you understand how to do? Okay. Okay. For example, this one is CH2, this one is also CH2, right? But the molar mass is different. So which molecule is bigger, F or C? C, because it is 70, because 70 is bigger than 42, right? So you just take 70 divided by CH2. Carbon is 12, hydrogen is 1 times 2, so 14. So you just take 70 divided by 14. How much you get?
Right?
Yeah. Okay. So then all you need to do is this one times 5. So it's C5H10. Get it? Okay, do the rest now. Quick, quick, quick. This one doesn't take you long much time. Ready? Yeah. Okay. So this one, 42 divided by 12, you get 3. So it is C3H6. Right? This one is 78 divided by 13, you get 6. Correct? So it's C6H6. Okay. Phosphorus is 31. Hydrogen is 1 times 3. So you get 34. So this one, the formula is the same because n equals to 1. Okay? Okay, and this one, last one, n equals to 2. So it's C4H10. 10. Easy, right? Okay, so we're going to do one last thing with this. Okay, please turn to the same page, this one, same page. Look at question 7. If you can do 7 and 8, then we're done with this part. Then we do something else. Okay, please do 7 and 8. All right, so phosphorus, oxygen, divide 31, divide 6. Okay, so did you get P2O3? Yeah? Do you know how I got P2O3? Yes, no? No, okay. So, 6.4 divided by 31, 1.819. And then 23.6 divided by 16, 2.725. Remember what I said? Divide smallest number. Okay? So you take both of these numbers, divide 1.819, you will get 1 to 1.5. Get it? And then you multiply 2, 3. Get it? Okay. So what you must understand is that is just the empirical formula. So this one is just the empirical formula, okay? We haven't counted the molecular formula. All right, so they give you is 220. So 220 over P2O3, 31 times 2 plus 16 times 3, 110 equals to 2. So P2O3 times 2 equals to P4O6. So this one is molecular formula, and this P2O3 is empirical formula. Understand? Okay? Okay. Now, last one. Ayo, so many to got 6.7 carbon. Oh, sorry. That's hydrogen. 6.7 of hydrogen. Carbon 40.0 and oxygen 53.5. Okay. So divide by 12, you get 3.33, 6.7 divide by 1, and then divide by 16, 3.33. So you get CH2O, correct? Okay. And then you take 60 divided by 12 plus 2 plus 16, 30. You get 2, so times 2, C2H4O2. Okay, so this is empirical formula and this is molecular formula. Okay, got it? Okay? Alright, easy, yeah? Okay, finally we can go to the next topic. So the next subtopic is this one. Next formula. Formula of gas. Okay? The formula of gas. Okay, can you please write this down as notes? Moles equals to volume over molar volume. This is only specifically for gas. Okay. Now, let's say I have 4 balloons. Okay. This balloon has 1 mole of hydrogen gas. This balloon, have I taught you this before? No, right? Helium gas, 1 mole of carbon dioxide, 1 mole of nitrogen. Okay? What I want you to do is tell me the mass of each balloon. Okay, draw this, write this down, and find me the mass of each balloon. The mass of 1 mole is the molar mass. Don't look so confused. Mass of 1 mole is molar mass. Okay? Do you have medicine or not? You bit on it accidentally. Also sucks. It really sucks. Ariel, you must watch the recording, Ariel. No, no, thanks. Just only finished. Today is Taekwondo. Not bad.
I mean, they don't ban. What's that?
Taekwondo is what?
Shorts.
No, it's in school or outside?
Issue.
In school also.
Later.
Oh, okay.
So,
Okay. As long as you watch the recordings, okay? Okay. What is the mass of the balloon with 1 mole of hydrogen in it? If you don't know this, I will sit there and cry. Ah. How many grams? 2 grams. Hydrogen is 2. 4 grams. 44 grams. 28 grams. Did you get that?
yeah.
Yes, sir. Okay. Now, what about the size of the balloons? Size of balloons depends on the volume. Okay. Now, here's the cool part. Every single balloon is a different mass. 2 gram, 4 gram, 44 gram, 28 gram. But every single balloon is the same size. It is exactly 24 decimeter cube. Okay, 1 decimeter cube is 1 liter. 2 liters is about the size of Ariel's water bottle. Okay, so the balloon is 12 water bottles big. Can you imagine? So about, let's say, 12 water bottles like this. This is the size of the balloon. So this balloon, if it's filled with hydrogen, is only 2 grams. Is that really light or really heavy?
Light.
Very light. If it's filled with helium, it's 4 grams. Still very light. Air is made out of 78% nitrogen. If I blow a balloon, I will be adding carbon dioxide and nitrogen into the balloon. So will my balloon be heavier or lighter than air? Heavier, so it will sink. So when I was a kid, I always saw people, the children in cartoons or in TV show, they hold the balloon can fly one. I'm very excited. Then whenever I get a balloon, I blow the balloon, my balloon always sink. So then my brother used to say, oh, because you're fat. Your air is very fat, so the balloon will sink. So now we know it's not the case, it's density. Correct or not? Okay, it's density. So what happens is the air you blow out is carbon dioxide and nitrogen. But the air that is pumped into the balloon is hydrogen or helium? Helium. Okay, it's helium. But why they put helium? Why not hydrogen? It's what? But hydrogen also light, ma. Which one is easier to get? No, hydrogen is easier to get. Hydrogen is what? Yes, hydrogen is flammable. How do you test for hydrogen? Test for hydrogen is you take a what splint? Burning splint. You take a light splint or a burning splint, and then you put there, it will pop. Right on. The popping one is hydrogen gas. The relight is oxygen. A little bit of hydrogen, a small pop. A lot of hydrogen, a kaboom. Okay. Many years ago, there is this thing called, yeah, the balloon. Handing others was well. Okay, explode. Hindenburg. Okay. So many years ago, okay. So a German, it's a passenger airship, Hindenburg, caught fire and was destroyed in 34 seconds. 34 seconds. Okay. So while attempting to dock Naval Air Station at New Jersey, it's highly flammable hydrogen gas. 36 people dead in 34 seconds. Okay. Wow, 97 people, wow, one third died. Still got people survived. I'm quite impressed. Okay.
You jump down.
I also don't know. Maybe they jump. Okay, maybe it's over ocean there. They jump down. Maybe they jump down, or maybe they jump down. They got burns, but not that bad, not that severe. Catastrophe incident unfolded a Zeppelin maneuver to drop these mooring lines, uh, leaking gas that allowed hydrogen to mix with oxygen. Okay, if you have pure hydrogen, it won't explode. But the moment hydrogen is mixed with oxygen, it will explode. So you're like playing with your life lah. So nowadays, I mean not nowadays, people don't sell hydrogen balloons, they sell helium balloons. But hydrogen balloons is cheaper. And some people actually will sell hydrogen balloons because it's cheaper. And then the little kids will be singing happy birthday to you, and then the candle is then kaboom and everyone dies.
Oh.
It's so dangerous. It's so dangerous. Okay? Okay? So the balloons are all exactly the same size because gases follow this concept. And this concept is also discovered by Avogadro, in case you're wondering. 1 mole of any gas is 24 decimeter cube at room temperature pressure. You only learn room temperature pressure. In SPM, you will learn standard temperature pressure as well. Okay? But in IG, you only learn room temperature pressure. So 1 mole of any gas is 20. So that means, oh, teacher, any gas means any gas. Yeah lah, any gas means any gas lah. So 1 mole of carbon dioxide, 24 decimeter cube. 1 mole of nitrogen gas, 24 decimeter cube. So if I have 0.5 mole, 12 lah. Okay? But what if I give you a random number? I give you like 32.6 decimeter cube. How am I supposed to find the mole? There comes our second formula. Amount of moles for gas only is volume over molar volume. Molar volume is the volume of gas. So you take 32.6 over 24 like that. Can you understand? Okay. So the only thing is this must be in the unit of decimeter cube. Decimeter cube. So if it's in the unit of centimeter cube, you must divide. So 1 decimeter cube is 1000 centimeter cube. Okay? Okay, can you write this down? Calculate the we do just simple questions, okay? Just a few. Okay, calculate the amount of moles in 36 decimeter cube of oxygen and 12000. centimeter. Okay, let's just try two simple questions. It'll take you like 3 seconds.
Calculator. What? No.
Yes, no, of course. IG only math paper 2 cannot use calculator. Okay, ready? So very easy, right? So you just take 36 over 24, get 1.5 more. Then this one, 12000, you just divide 2 pound 000. Okay, so you get 0.5. Get it? Simple, right? Okay. Now, can you find the of mass of 0.36 centimeter cube of oxygen gas? Okay, write this down and find this. Okay, 0.36 centimeter cube of oxygen gas. So remember, I've only taught you two formulas so far, two only. Please use both. Use your brain and use both. Okay, so first of all, you find the moles is 0.36. Remember, it's 24,000. Okay? I put centimeter cube. So it's how many zeros? 4 zeros. Okay, so this is moles. How to find mass? Moles multiply molar mass. Because if moles is mass over molar mass, then moles just the other way around. Correct or not? So you take 0.000015 multiply how much? What is the molar mass of oxygen? 32. Oxygen must exist as O2. Remember your best friends F2, Cl2, Br2, I2, O2, H2O2. Always must exist as 2. O2, H2. Did I forget somebody? N2 is supposed to be N2. I said N2 there. Okay, 0.00048 grams. Okay, so it's very, very light. Yeah. How much is 0.36 centimeter cube? It's a little bit, but it's really, really light. So that's the whole concept. Okay, so how many formulas we learned so far? Two. I will teach you the third one next week. Okay, so what I want you to do is turn back to this paper, the second paper, the one that I just gave you, son. Okay, look at question 1. Okay, question 1 is empirical formula. I want you to do that as homework. Question 1 is empirical formula. You will know what's empirical formula when you watch the video. Okay, Ariel? Okay. All right. Wait. Listen first. Okay, question 2 is accumulation of everything we learned. Ratio and mole. Okay, I want you all to do question 2 now. You finish question 2, then I will let you go in peace. If he messaged me, I don't know. Maybe not now. Oh no. Okay, first you find the amount of moles of ammonia. 0.68 over 17. Okay, I give you steps. Then you use the ratio. Ammonia. Okay, step 1. Step 2, I give you steps. Okay, ammonia to chlorine is 2 to 3. Then you find the moles of chlorine. Okay? And then step 3, you find the volume of chlorine. Alright? Step 1, step 2, step 3. Step 3 is you find the volume lah. You find the moles. Step 2 is you find the moles of chlorine. Then step 3 is volume of chlorine. Volume is moles times molar volume times the 24,000. The one that we did just now. Get it? Okay, if this one is 0.04, how much is chlorine? 0.06. So then you take 0.06 multiply. What is molar volume? 24,000. Why do I use 24,000? Because here is cm cube. Get it? Alright. Go home and finish the homework. Hey, don't you finish? Wait. I want to tell you homework, but some are still copying it. Okay. All done already? So homework is question 1, question 3, 1 and 3, 1 and 3, 9, 10, 11, and 12. Okay? I will send this to you. Alright? Okay.